Hey guys, it's Red here. I've got some calculus for you today from the Unit 3 Maths Methods course. Essentially I wanted to step you through the key 3 rules that you learn in differentiation, being the chain rule, the product rule, and the quotient rule. And so I've got an example for each of them today. Now, you'll see on this page I've actually just stepped it out into these 2 columns. If you're learning these 3 rules for the first time, I'm going to do on the left side here more of an introductory or a slower step-by-step method. Once you're more experienced and comfortable in using the rules, there's a bit of a faster, more efficient way to just take these derivatives more directly, and I definitely encourage you to be learning and getting faster and then being able to do it this way to save yourself time in SACs and exams. So I'll just step you through. Hopefully you've seen these rules before, but we have the chain rule. dy dx is dy du times du dx. The second one here, the product rule, where we have a product of 2 functions, y is equal to u times v. We have the derivative dy dx is u dv dx plus v du dx. And finally, the third quotient rule, where y is a function of u divided by v, so one function divided by another. We have dy dx is v du dx minus u dv dx over the v squared. So let's get stuck into it. So using the first way, the basic way, so we'll say let u equal to the 6x plus 1, this inside here, and then du dx, I'll take the derivative of this with respect to x, just get 6. Okay, now because I let u equal the 6x plus 1, I can rewrite y as simply u to the power of 9. Now I can work out dy du, which is 9u to the 8, and substituting it back in for, remember how u is 6x plus 1, I get 9 6x plus 1 to the power of 8. Okay, so now I just want to put the parts back together. So dy dx is equal to dy du times du dx, which is equal to dy du is here, 9 6x plus 1 to the power of 8 times by du dx, which was 6, and I'm left with 9 6's make 54, 6x plus 1 to the power of 8. Okay, and that's it for applying the chain rule and the derivative. Now, for those of you that are a bit more advanced and can do this quickly, the way I like to take a chain rule, the derivative, f dash of x is simply the derivative of the inside thing multiplied by the derivative of the outside thing. I'll show you what I mean by that. So I'll do these in red. So f dash of x is equal to the derivative of the inside here. The inside thing is 6x plus 1, so the derivative of that is just 6, multiplied by the derivative of the outside. So I'm basically looking outside these brackets. So the 9 would come down out the front. 9. The stuff in brackets stays the same. And then we drop the power by 1. So the 9 becomes an 8. Now I neaten this up. 9 6's are 54. 6x plus 1 to the power of 8. Now you can see just how much faster that was to get to the same answer, which I've done in 2 lines here, compared to all of this working out. So as I said earlier, if you're learning for the first time and getting familiar with how to apply these rules, you're using this method, hopefully moving towards getting faster. Okay, the next one is a product rule. The way I can identify this is that I have one product here, x cubed, being multiplied by another product, e to the 5x. Okay, so let u equal the first thing, which is x cubed, and then v is going to be the second function, which is e to the 5x. Now I'm going to take the derivative of u, du with respect to x. That gives me 3x squared. And then I'm going to take the derivative of v with respect to x. Now, when we derive e to the 5x, we've got the derivative at the top here, so this 5, and then e to the 5x. Okay, so now I'm going to apply the product rule, which is simply dy dx is equal to u times dv dx plus v du dx. Okay, now noting here u times dv dx and then v times du dx. So it's a bit of a crisscross. So u is x cubed times dv dx 5e to the 5x plus v, which is e to the 5x, times u, which is 3x squared. Okay, now when you're doing these questions, you usually want to simplify down and collect any like terms, etc. So looking at these, we actually have a common factor here of the x squared and the e to the 5x. So if I take that out the front, x squared, e to the 5x, out the front of the 5x plus 3. Okay, so that's the end of that. Now again, if I just come over here and look at this quicker or more advanced way, for my product rule, I'm basically saying the derivative is the first thing, or the first function, times the derivative of the second, plus the second function times derivative of the first. So, applying that here, f dash of x is equal to first, which is x cubed, times the derivative of the second, 5e to the 5x, plus the second, e to the 5x, times the derivative of the first, 3x squared. Neaten that up, same as what I had before. E to the 5x, 5x plus 3. So you can see again just how much faster that is to take a derivative directly using that alternative first and kind of second terminology. Okay, and the last rule that we've got now is a quotient rule, and the way I can tell is I've got a sign on the top here and the x squared plus 6, so one function being divided by another function. Alright, let u equal to the top, sine x, du dx, derivative of sine is cosine, cos x, v is equal to the x squared plus 6, the bottom, and dv dx is equal to 2x. Alright, applying the quotient rule, dy dx is equal to v du dx minus u dv dx all over v squared. So again, u dv dx, and that v du dx. So x squared plus 6 du dx is cos x minus, now just be careful with your brackets here guys, I like to put in these big square brackets because sometimes it's easy to forget a negative, so sin x times, in this case it won't matter too much, 2x divided by the v squared, which is x squared plus 6 all squared. Now usually what happens next is there's a bit of simplification and work that can be done to just tidy this up and cancel things, but in this case there's not really too much you can do. So x squared plus 6 cos x minus 2x sin x all over this squared. Okay, so that's probably the hardest or the trickiest rule to apply. Finally, let's do it the quicker way. So to find this derivative, what I'm going to do now is say bottom times the derivative of the top minus, watch out for your brackets, top times derivative of the bottom all over the bottom squared. Okay, so applying this, it's f dash of x is equal to bottom x squared plus 6 times the derivative of the top, derivative of sine is cos, minus top, which is sine, times the derivative of the bottom, which is 2x, all over the bottom squared. X squared plus 6 all squared. And then, if required, you'd go through and neaten that up. But again, as we find here, there's not too much you can do to cancel things. X squared plus 6. So again, same as what we got before, but much more quickly and directly. That's it for this video. Thanks for watching guys. As always, feel free to like and subscribe. Good luck with calculus and good luck with methods.